The monsoon in India is typically bunched into spells of intense rain. Rain falls very intensely within a few hours, within a few days, within a few months of every year. The number of rainy days does not average more than 40 to 50 days in most parts of the country. The challenge is to find ways of using this water where it falls. For years, our development planners have allowed the rain which falls in every village of our country to flow out into the rivers as runoff, and then tried to bring this water back to the villages by building large and expensive dams and canal networks. Watershed development aims to precisely reverse this process, to stop and conserve water where it falls within every village, so that it can be retained and used for a longer period of time. A watershed area can be visualized as a landscape shaped unevenly like a bowl or basin. When it rains, water flows down from the top of this bowl to collect at the bottom. So the hills, valleys, forests and fields that encircle the falling rain and guide it to its streams and rivers all form the enclosure that is the watershed, the catchment area where a river catches its water. The size of a watershed may vary from a few hectares to thousands of square kilometers. A unique feature of watershed approach is that it is very location specific. Within a watershed, there can be very different conditions in terms of soil, slope and vegetation. Watershed interventions vary according to the variations in each of these. But broadly, watershed interventions follow a basic principle of ridge to valley approach, treating the entire area from the ridges to the valleys within a watershed. We thus have a progressive series of ecological units, each a watershed at a particular level of group of interventions. Within a watershed area, the slopes falling from the ridges are called the ridge area. The many channels that flowing rainwater drains into are called drainage lines. Gullies, streams and rivers are all drainage lines. The difference between a gully, a stream, or a river is the size of its catchment area. That is, the larger the expanse of land that collects and drains water into a channel, the bigger the stream of water will be. Since the primary concern of watershed development is to catch the rain, we have to understand the nature of rain. How much of it falls, how fast does it fall, and the quantum of rain that will actually flow as runoff. These parameters are critical for planning the size and location of watershed structures. A meticulous calculation is done of the watershed area prior to designing of the actual work. For this, it is important to plot the area on a topographical map of that particular region. The area is calculated with the help of a graph paper, and then runoff is derived according to the type of geology of the region. The slope, soil and rainfall together determine the runoff. Once we know how much water is expected to flow into the structures, we need to design it so that the structure either slows down the speed of runoff or can store an optimal proportion of this water. Here we must accept that it is neither possible nor desirable to harvest every drop of rain that falls in a micro watershed. Some water must be allowed to flow for use in villages downstream. This flow is also vital to sustain the ecosystem, including the monsoon cycle itself. The approach of watershed must be guided by the principle of balance. Whatever we draw from Mother Earth, we must return to her. Watershed interventions must begin at the ridges. A typical mistake is to begin by constructing a water harvesting structure in the lowest part of the watershed without treating the upper part of the catchment. The result is a rapid silting up of the storage capacity created because of the soil erosion in the upper part of the catchment. Thus we must begin with the treatment of the ridge area, followed by the smallest drain, moving on to the larger and larger drains in the watershed, arresting the runoff at each point. Since watershed works essentially tries to regulate the momentum of water flowing down the slope, calculation of elevations and slopes is essential for deciding on the type of watershed structure appropriate for each location.
64, 143.
एक 24 एक 15
On slopes greater than 25%, the only intervention possible is to protect natural vegetation and plant a variety of species appropriate and native to the area, as no man-made structure will be able to withstand the speed of flowing water. On slopes between 10 to 25%, we construct contour trenches. Contour trenches are trenches dug along contour lines. Contour lines are lines joining points of same height. Trenches are a simple method of reducing the speed of water running down the slope. This improves local soil moisture and traps silt. As we move further down the ridge area on the slopes less than 10%, we construct contour bunds, simple low-cost mud structures for checking the velocity of water running down the ridge area of any watershed. Like trenches, contour bunds check soil erosion and improve local soil moisture. On small drainage lines or seasonal streams, we construct boulder checks or gully plugs. Boulder checks are very small dams made of loose rocks or boulders. They are made on small, seasonal streams where the bed slope of the stream is less than 20% and the catchment is under 50 hectares. Each boulder check will not have an independent catchment area of more than 1 to 2 hectares. Boulder checks are usually made as a series on a drainage line. The main objective of constructing these rock dams is not so much to harvest rainwater, but to reduce the speed of water flowing through the stream. This helps reduce soil erosion and increases the duration of water flow in the streams. On to bigger streams, with a catchment area of 50 to 500 hectare, we construct gabions. These are streams where the volume and velocity of runoff is too high for loose boulder checks. Gabions are also boulder dams, but they are much bigger than boulder checks, and here the rocks are held together with wire mesh. Like boulder checks, gabions also slow down the water rushing through the stream, helping to increase the duration of water flow and recharge groundwater. They also trap silt that reduces the rate of sedimentation in dams built downstream. These structures hardly cost a few thousand rupees, but their cumulative impact is truly remarkable. Built in the ridge area of a watershed, they slow down the velocity of flowing water, reduce soil erosion, and rejuvenate dried up streams by increasing the duration of their surface water flow. They also induce base flows that recharge water harvesting structures downstream even after the monsoon. By arresting silt in the ridge areas, they help increase the life of these dams. In this way, ridge area treatment ensures that the money spent in building dams in the lower reaches of a watershed gives us maximum results. One of the key interventions in any watershed program is the earthen dams built on the main stream of the watershed. Earthen dams are constructed on a relatively flatter portion of the main watershed stream where the bed slope is less than 5% and with high and firm embankments. Earthen dams are simple, small, low-cost structures that imaginatively utilize local resources and local knowledge. They show how, through a watershed approach, rainwater can help drought-proof agriculture, transform landscapes, and bring about dramatic improvements in rural livelihoods. On the flatter land in the farm fields, ponds are constructed to harvest rainwater which otherwise would have flowed out of the farm. The main objective of such structures is to provide protective irrigation to the monsoon crops. There are several days in succession in the rainy season when there is no rain. Such dry spells may actually ruin the kharif crop. Dugout ponds protect against such crises.
Yeah. Yeah.
A very important watershed intervention in the farm is the farm bunding, designed to arrest soil erosion. These bunds also help improve the soil moisture profile by arresting water flow out of the farm. Rainwater carries off with it precious topsoil. Due to this action of rainwater, rills are formed in the fields which soon become small drains. Every year in our country, 6.6 billion tons of topsoil and 5 to 8 million tons of nutrients are lost due to soil erosion. India is losing soil 30 to 40 times faster than the natural rate of replenishment. It actually takes over 10,000 years to form a 2.5 centimeter thick layer of fertile soil. If these soil losses are prevented, the productivity of agriculture can rise by 30 to 40%.
पहले यहाँ फसल का ही है, ये सब धुआई जाती थी। ये पालू बांधा नाम से ये सब गारू रुकाई थी यहाँ। ये पाला भराई ना से ये उतरो गारू रुकाई थी यहाँ। ये पाला नहीं होता तो ये सब नदी में जाते रहते। मैंने ये पाला बांधा नाम से रुकाई है।
These watershed structures, made out of locally available material, are very simple and can be executed and mastered by the local people themselves, creating permanent assets for the area. The aim of watershed management is not to pose mastery over nature, but to seek solution in achieving environmental regeneration, create livelihood and water security as well as people's empowerment.
Thank you.